This topic block introduces you to the electric parking brake and the systems associated with it. It deals with the following topics: the design of the electric parking brake, and how it is applied to prevent the vehicle from rolling away when parked. However, it also examines the interaction that takes place between the electric parking brake and the adaptive brake system, when the vehicle is stopped temporarily, for example, or when the convenience application and release functions are used. The electric parking brake also teams up with other vehicle systems, but more about that in the section on the standstill coordinator. Finally, you will study operation of the parking brake while the vehicle is moving and when pulling away uphill. The parking brake comprises duo-servo drum brakes located inside the bowls of the rear wheels. They are operated by means of two cables. Instead of leading to a foot-operated brake pedal, these cables are connected to the electric parking brake control unit on the rear axle. Move the cursor over the diagram to familiarize yourself with the components. Click on the electric parking brake control unit to take a closer look at it. The electric parking brake control unit contains the electronic control, an electric motor with spur gear, plus a spindle drive. The right-hand cable terminates in the drive's threaded rod, while the left-hand cable is connected to the accompanying threaded sleeve. The threaded sleeve can be moved lengthways, but its connection with the spur gear is torsionally rigid. A cable force sensor designed on the principle of a strain gauge measures the tensile force of the cables. The emergency release cable is able to unlock the tensioning mechanism so that the parking brake can still be released even in the event of electrical failure. The emergency release procedure is not described here. Please refer to the vehicle's owner's manual for details. The electric motor turns the spindle drive's threaded sleeve via the action of the spur gear. The cable's threaded rod screws into the threaded sleeve, resulting in the cable being pulled. The movement of the sliding threaded sleeve causes the other cable to be pulled taut too. The electronic control uses the cable force sensor to determine the tensile force in the cables. The cables are pulled until a predefined tensile force is reached. After the electric motor has switched off, the gear's self-locking design ensures the tensile force is maintained even when the control unit is no longer active. To release the parking brake, the servo motor is actuated in the opposite direction to relieve the tension in the cables until the return springs have opened the parking brake shoes again. Click on the electronic control if you would like to see the parking brake being applied and released again. As you are bound to know, the law requires that the force is transmitted mechanically in parking brakes, and that the energy accumulator is also mechanical. Does the electric parking brake comply with this legislation? Label the electric parking brake components illustrated here by placing the component names in the correct positions. The handle for operating the electric parking brake can be found in the same place as the parking brake release handle on the preceding model series. The foot pedal for the parking brake is no longer fitted. This reduces the risk of drivers sustaining injuries to their legs and feet in the event of an accident. Pushing the handle when the vehicle is at a standstill activates the parking brake. Here, standstill means that the vehicle's speed is below 3.5 kilometers per hour. In other words, the parking brake can also be applied when the vehicle is coasting very slowly. Later we will take a look at what happens when the handle is pushed in at higher speeds. How can the parking brake be released? What condition needs to be fulfilled first, in your opinion? As you know, the mechanical parking brake is used in many different situations. When waiting at traffic lights or a railway crossing. When stopping temporarily. For hill starts. And, of course, for securing the vehicle when parked. The electric parking brake can also be used in all of these situations. In actual fact, though, the electric parking brake is only really needed for securing the vehicle when parked. The new hold and hill start assist functions come to the driver's aid in other situations. These functions make use of the service brake as opposed to the parking brake. The hold function is activated by depressing the brake pedal a little harder again once the vehicle has come to a halt. If the brake pedal was depressed forcefully to bring the vehicle to a halt in the first place, it can be released a little and then briefly depressed again. The next screen shows you how it works. Activate the hold function by clicking on the brake pedal twice. Brake pressure is built up with the aid of the brake booster by actuating the BAS solenoid valve. This pressure is maintained until the driver presses the accelerator pedal. Try this out for yourself. When the accelerator is pressed, the BAS solenoid valve returns to its idle state. This equalizes the pressure in the two chambers of the brake booster. The braking effect ceases and the vehicle starts to pull away. The hold function can also be deactivated by pressing the brake pedal again. For which of these situations is the hold function particularly handy? If hold has already been activated and the ignition key is removed, the task of securing the vehicle will automatically be transferred to the parking brake. In other words, there is no need to push the parking brake handle. This feature is referred to as convenience application. On vehicles fitted with keyless go, the signal for transferring to the electric parking brake is triggered when the driver's door is opened. The individual processes involved in convenience application are as follows. The parking brake control unit pulls the parking brake cables taut. The BAS solenoid valve is de-energized again. The pressure in the brake booster's chambers is equalized. The diaphragm returns to its rest position and the service brake pressure drops to zero. Convenience application is complemented by the convenience release function. Once the driver has closed the door and buckled the seatbelt, turned on the engine, and depressed the accelerator pedal, the parking brake will be released automatically. There are situations in which the parking brake cannot be released automatically. This is the case, for example, if one of the conditions is not fulfilled or a signal has failed. What happens if the driver tries to accelerate away? Click on the accelerator pedal to see. If the driver continues to press the accelerator pedal without heeding the instrument cluster display, an audible warning will be emitted and a warning message will appear in the display. In this case, the parking brake must be released manually by pulling the handle. If the electric parking brake is inoperable for any reason, for example, if one of the brake cables snaps and the cable force sensor indicates zero tensile force, the Stand Still coordinator will be activated in the parking brake control unit. The Stand Still coordinator then instructs the automatic transmission to engage the parking lock to secure the parked vehicle, even if the selector lever was not previously in position P. To do this, the automatic transmission's intelligent servo module moves the range selection lever into the corresponding position. Here's another situation for you to consider. Click on the selector lever to engage the parking lock. If the automatic transmission's parking lock cannot be engaged, a message will again be sent to the standstill coordinator in the electric parking brake. Instead of the parking lock, the parking brake will now be applied to prevent the vehicle from rolling away. You have learned about various different methods for securing the vehicle when it is stationary. Now it's time to find out what happens when the parking brake handle is pressed while the vehicle is in motion. That is, when it is travelling faster than 3.5 kilometers per hour. Press the parking brake handle. In this situation, the electric parking brake does not apply the duo-servo drum brakes. Instead, it assumes the vehicle is in an emergency braking situation and commands the hydraulic braking system to apply the brakes at all four wheels at a constant 40% of full braking power, corresponding to a deceleration rate of 4 meters per second squared. The brakes continue to be applied until the vehicle comes to a stop or the handle is released again. If necessary, the ABS and ESP systems can take corrective action. In the case we just saw, the emergency braking situation was provoked by a driver-related factor. For example, leg cramp or objects in the footwell blocking the brake pedal. If, however, the service brake itself should fail, pressing the parking brake handle will result in the parking brake's own duo-servo drum brakes being applied. This is the only situation in which the electric parking brake will risk unregulated application of the brakes at the rear wheels. Hill starts represent a specific situation. The vehicle must not roll backwards while the driver switches from the brake pedal to the accelerator. Hill start assist is included as part of adaptive brake. It makes light work of hill starts without the driver having to resort to the parking brake or the hold function. How is the adaptive brake control unit able to detect a hill start? If a hill start situation is deduced from these sensor data, the hill start assist function goes on standby. If the driver now releases the brake pedal, the brake pressure does not drop. Instead, the hydraulic unit is actuated to maintain a brake pressure appropriate to the vehicle's angle of inclination. If necessary, the pressure can even be increased to hold the vehicle securely. This pressure continues to be maintained until the accelerator has been pressed far enough for the engine to build up the necessary tractive force. In this way, the hill start assist is able to prevent the vehicle from rolling back unintentionally while the driver switches from the brake to the accelerator pedal. However, the brake pressure is only maintained for a maximum of 1 second, after which time the pressure will definitely drop. Consequently, it is possible to let the vehicle roll after a brief wait. In which of these situations will Hill Start Assist briefly hold the vehicle stationary? Click on the applicable scenarios and confirm by clicking on OK. How high is the brake pressure applied by Hill Start Assist? Click on the appropriate. First, take a look at how the conventional Distronic proximity control system works. When the road ahead is clear, Distronic works in the same way as the standard cruise control system by maintaining a constant cruising speed without the driver having to operate the accelerator pedal. In heavy traffic, the system deploys a radar sensor to calculate the distance to the vehicle ahead and maintains a safe distance, which varies depending on the current speed. To do this, it is able to regulate the engine and transmission control as well as use the vehicle's brakes. Distronic has now been redeveloped to produce the more advanced Distronic Plus system. See how Distronic and Distronic Plus compare with one another. Distronic is operable from 30 up to 180 km per hour. The maximum rate of deceleration that Distronic can elicit from the vehicle's brakes is 20% of the vehicle's full braking power, corresponding to a rate of 2 meters per second squared. Compared to Distronic, Distronic Plus is operable over a wider speed range, which extends from 0 up to 200 km per hour. The maximum rate of deceleration has been doubled with Distronic Plus, meaning that it is now equal to 40% of the vehicle's full braking power, or 4 meters per second squared. The crucial advantage that the new system holds over Distronic is that it is now able to brake the vehicle to a halt. This has been made possible by the addition of extra short-range radar sensors. Now compare the characteristics of the respective radar sensors used by the Distronic and Distronic Plus systems. Distronic features a 3-part long-range radar sensor with a range of 150 meters and a total angle of coverage of 9 degrees. Any vehicles ahead can be detected reliably up to a distance of 100 meters. Vehicles with Distronic Plus are equipped with a similar long-range radar sensor, which now has the DTR control unit integrated into it. The angle of coverage is unchanged at 9 degrees, as is the maximum range of 150 meters. Again, the system is capable of detecting vehicles ahead reliably up to a distance of 100 meters. Distronic Plus comes with additional short-range radar sensors. These sensors cover the area up to 30 meters in front of the vehicle and have an angle of coverage of 80 degrees. The primary benefit of the short-range radar sensors is that they enable proximity control to be carried out at lower speeds, all the way down to stationary, as the vehicle ahead can be reliably detected even at close distances and wide angles. Here you can see an overview of all the radar sensors, taking the 221 model series as an example. The difference between the short-range radar sensors and the long-range sensors is their operating frequency and radiation characteristics. Apart from Distronic Plus, BAS Plus, Brake Assist, and the Park Assist system also make use of the radar sensors. Move the mouse cursor over the sensors to display their respective applications. But how does Distronic Plus work together with adaptive brake? Let's assume that the distance to the vehicle in front drops below the driver's set value when the vehicle is still some way ahead. The corresponding readings will be registered by the long-range radar sensor, evaluated by the DTR control unit, and transmitted to the radar sensor control unit. If, on the other hand, the distance drops below the set value when the vehicle is much nearer, the readings will be registered by the short-range radar sensors. These likewise relay the data to the radar sensor control unit. Once all sensor data have been evaluated, the radar sensor control unit carries out all the calculations required for regulation of the vehicle's straight-line velocity. The signals, which are subsequently transmitted to the adaptive brake control unit, contain commands for accelerating or slowing down the vehicle. Now take a look at the different ways in which adaptive brake can intervene when Distronic Plus is regulating vehicle proximity. Depending on the situation at hand, the adaptive brake control unit can intervene via the engine control, the transmission control, or the braking system control. The brakes can be applied, for example, by actuating the BAS solenoid valve in the brake booster. This adjusts the vehicle's speed sufficiently to restore the distance set by the driver. Now take a look at the benefits of Distronic Plus. Once the system has detected a vehicle ahead, it maintains the driver's set distance by braking or accelerating. The set distance is automatically adapted as the vehicle's speed changes, although the minimum distance stipulated by the law is maintained at all times. Click on the vehicle ahead to watch what happens when it brakes to a stop. Distronic Plus tracks the vehicle ahead, right down to the point at which it is stationary, and applies the brakes of your vehicle accordingly. The proximity control function then switches off. If the vehicle ahead pulls away again, Distronic Plus will not follow suit until instructed to by the driver pulling on the cruise control lever or briefly pressing the accelerator pedal. In this way, Distronic Plus is able to take the strain off the driver, particularly in stop-start traffic. Over what speed ranges are Distronic and Distronic Plus active? Which radar sensors does Distronic Plus use? Click on the radar sensors in question. Before we take a look at the auxiliary BAS Plus function, let's remind ourselves of how the conventional brake assist function works. Click on the brake pedal. In an emergency braking situation, many drivers press the brake pedal very quickly, but do not depress it with the necessary force. The diaphragm travel sensor transmits a signal to the adaptive brake control unit. This signal corresponds to the brake pedal's position. Based on the speed with which the brake pedal was depressed, the control unit is able to recognize an emergency stop and energize the BAS solenoid valve. The solenoid valve vents the work chamber, boosting brake pressure up to the threshold at which ABS would cut in. BAS is deactivated again either when the brake pedal is released or just before the vehicle comes to a stop. This familiar brake assist function continues to make up part of adaptive brake. Models which are equipped with Distronic Plus come with an auxiliary function known as BAS Plus, in addition to the conventional brake assist. To enable it to assess the traffic situation, BAS Plus is able to make use of the Distronic Plus system's radar sensors. Click on the radar sensors to look at this in detail. The radar sensor control unit combines the data from the long-range and short-range radars to evaluate the road users detected ahead. If a stationary obstruction is detected, such as the end of a tailback, the control unit calculates the required rate of deceleration. This information is then relayed to the BAS Plus brake assist in the adaptive brake control unit. Now watch how BAS Plus works when the Distronic Plus system is activated. If the distance to the vehicle ahead drops below the set distance, Distronic Plus will intervene by instructing that the brakes be applied. To do this, Adaptive Brake actuates the solenoid valve in the brake booster to build up the required brake pressure. The vehicle is then braked at a rate of up to 4 meters per second squared. The driver is alerted to situations which require a higher rate of deceleration than this by a warning lamp in the instrument cluster and an audible prompt. These warning signals instruct the driver to assess the traffic situation and, if necessary, take evasive action himself by braking and steering. After being prompted by the warning, the driver becomes involved in the braking maneuver initiated by Distronic Plus. Click on the brake pedal to see what happens. Signals sent by the diaphragm travel sensor in the brake booster and the pressure sensors in the hydraulic unit allow Adaptive Brake to detect the application of the brakes by the driver. The brake pressure built up manually by the driver is registered at the pressure sensor for the tandem master brake cylinder. The required rate of deceleration will have already been calculated by the radar sensor control unit using the radar data and relayed to the ABR control unit. The ABR control unit then calculates the brake pressure needed. If the actual pressure required is greater than that being applied by the driver, BAS Plus will take over and actuate the brake booster's solenoid valve accordingly. Consequently, the brake pressure is boosted to the required amount to avoid a collision, as far as is physically possible. In the most extreme case, this can even mean an emergency stop with the maximum possible rate of deceleration. If necessary, the ABR, ABS or ESP systems also take corrective action. What happens, however, if the driver has deactivated the Distronic Plus function? Click on what you believe to be the correct answer. As you are already aware, BAS Plus is able to increase brake pressure up to the threshold at which the ABS system would cut in, that is, as far as the laws of physics allow. To illustrate this, take a look at the following example. Click on the vehicle ahead to trigger a sharp application of the brakes. As you can see, BAS Plus alone is unable to guarantee that the vehicle can always be brought to a halt before it collides with the detected obstacle. Rather, it is the driver's responsibility to maintain a safe distance as dictated by the driving conditions and the traffic situation, and to brake at the very latest when prompted to by the warning. Can you describe the sequence of events when the vehicle needs to be braked heavily with Distronic activated? Arrange the individual events in the correct chronological order and confirm by clicking on OK. Can you describe the sequence of events when the vehicle needs to be braked heavily with Distronic? At what rate of deceleration does BAS Plus? You have now reached the test section of this CBT program and can select test exercises from this page. Alternatively, you can simply click on Next to proceed to the next exercise that has not yet been completed.